later on today, and whoever's not here or you want to hear it again, I can listen to it again. So there it is. I don't want to see transcription. Are there any questions, guys? Anybody, any questions? Yes, no, maybe so. Everybody good? Now, I wanted to show you something. Let's
Oh wait,
hope
I'm sorry. I had a question.
Okay,
I had
hold
a
on a
question. My
second.
mic wasn't unmuting. It's actually quite a few. So would it be all right if like I talk to you after the Teams is ended?
Okay, just give me one question. One question that maybe everybody else wants to know.
All right. I still don't understand. I was watching the videos and going through the textbook, but I'm having some trouble with solving the linear equations with the parentheses and the fractions.
Oh, that's a math question. We will do that today, so no worries there. I will start with section 1.1. So I will go for parentheses, I will go for fractions, I will do the whole 9 yards today. So that hopefully can be cleared. And if you still have questions, you know, you and I, we can get together and I will help you with those.
All right, thank you.
Cool. Any other general questions about Falcon Online, the course, anything? Now, since we're more people now, what I would like to do for everybody right now, just a second, of course, only if you're decent. If you could turn on your camera, because this is a practice run for whenever we have a test. Remember, when we have a test, you have to have the webcam on. So if you can turn one on, like I said, only if you're decent. I'm gonna click on large gallery. Ah, here you go. Michael is combing his hair. Cool. Cool. Okay, cameras are working. Anybody else? Gallery, let me see. Let me put on a large camera, a gallery for more people. The camera on this doesn't work, but next Teams meeting. Okay, cool. Lauren, thank you. Let me see if I can get a large gallery so I can see more people. Large gallery. Hey, yeah, hello. Cool. And we can even set together mode. Let's do that. You know, I like to play around with things. Here we go. We're all together. How cute. Okay. Anyway. Okay, so make sure your camera, you can turn your camera off. Make sure your camera is working by the time we have our first test. Of course, that will not be until about 2 weeks from today, or we'll see. Now I can, no, I tell you next week. Okay, so the one thing I wanted to show you out of, you see me in last class, I turned it on, but my place is still awake. Okay, Ashley, no problem, no problem. Lactose was bugging out. Yeah, that's why we're practicing today and we're testing, make sure the equipment does work, and we'll go from there. As you can see, I was trying to change the picture and that doesn't seem to work. But one thing I wanted to point out to you, because some of you already have emailed me, and also I've made the change, but at the end, when you're finished with the first quiz, which is section 1.1, you know, some of them are early starters. We haven't even covered it yet, but that's good. But what happens is, let me go to preview. If you solve, and there are only 3 questions, if you solve these 2 equations and you have to enter your answer, don't type in x equals. So I'm making this answer up now. If you say x equals 2, then it will mark you wrong, even so 2 may be the answer. 2 is not the answer here. But so whatever answer you have, if it marks you wrong, you probably have the correct answer. And I will go in there manually and change your grade. So no worries. I will look at everybody's quiz and look at the 2 problems and see if you have the correct answer. So if you haven't done it yet, and try to remember, don't put in x equals. That will mark it wrong for whatever reason that is. Okay, so that's really the only thing I wanted to point out. Don't forget the student acknowledgement form. Okay, 16 already have done it. And also don't forget the first introduction discussions. Just post a quick introduction about yourself to the course and so forth. You don't have to reply to anybody else, but if you read something, and like in my online course in statistics, I have a lot of nurses in there, so they reply to each other. Hey, I'm a nurse too. So if you want to reply to your classmates because they're watching something you're interested in on Netflix, then please feel free to do so. I just heard this morning on TV that Netflix right now isn't doing so hot because people are venturing out more. They really were doing great, during the height of the pandemic, but with vaccine and everything, I guess people are not watching Netflix. And also the Peloton, everybody, I guess, was doing inside at home exercising. So these 2 companies right now, I guess, are struggling a little bit. My little tidbit for the day I learned on the Today Show. I don't really have to do attendance verification right now because since everybody is in Teams, I get an Excel spreadsheet that tells me the attendance roster. Okay, if there are no other questions, then, like Tony Ann wants to get going, let's start with section 1.1. And like I said, did I say that? I'm using Doceri, so let's hope this is working. With my iPad, Meatloaf died. That, I mean, if you're my age, then you know Meatloaf is. That's really sad. I grew up on his music, with his music. Okay, if you have any comments, feel free to write them in the chat. I look at them. If I glance over there, that just means I'm in the chat looking at what you're saying. And please make sure you participate. Just give me the answer as you would in the classroom. I tried to do the forms, but somehow that was stuck when I polled the audience. So I will figure this out by Monday. So you should see now my name. Do you see my name? Somebody say yes. Do you see my name on the screen? Yes, okay, thank you. Also, I need a volunteer. I had that last semester. I had a volunteer who would always remind me to click on record because I tend to get talking and then half the class is over and I forgot to click on record. So who's my volunteer to remind me? Any volunteers? No?
I can remind you.
Okay, who is it? Tony Ann?
Yes.
Yes. Yeah, I see you blinking, so it must be you. Okay, thank you. You will be my reminder. Thanks. Okay, so we're talking about linear equations with one variable today. Now, we talked about linear already a little bit. We just glanced at it. So here I put down an example, x plus 2 equals 5. So an equation is really where two statements are equal. Let me just write this down here. A little bit definition. Two statements are equal. So what really happens, and somebody said, I think on Wednesday, said an equation must have an equal sign. That is absolutely correct. That is important. We need to have an equal sign. So an equation really consists out of two parts. So if I put a line here right by the equal sign, then I have a left side, as I call it, the left side, and the right side. So x plus 2 is the left side and 5 equals the right side. X is the variable. Somebody's coming in, hold on. X is the variable that we have to find, the unknown. We have to find that number in order to make the left-hand side equal to the right-hand side. And the way we do that is in form of doing opposite operation. I always say adding, subtracting, they're like brother and sister, as well as multiplication and division. So if we have x plus 2 equals 5, we need to isolate this x. So we need to get x by itself. We have a plus 2 attached. The way we get rid of this plus 2 is how. You can type in the chat, what do I need to do to get rid of this 2 on the left-hand side? Anybody? Minus, right. Subtract 2. Yeah, absolutely correct. So what I do is I'm going to say minus 2 to either side, because when we have an equation, whatever we do to one side, we have to do the same to the other side, or the balance is not there anymore. So if I say minus 2, now I usually put a line here. A plus 2 and a minus 2, they cancel each other out to 0. And what you have left on the left-hand side, you bring down the x, and then equals, and on the right-hand side, you do the arithmetic, and we all knew the answer was 3 here. Now, the beauty about solving equation, the beauty about math in general, there's many times you can check your answer and see if you're correct or not. So you even know it before I would look at your test. Oh, I got this right because it checked. So I don't do it enough, but if you check, we had x equals 3, and you replace the x with 3, then of course we have 3 plus 2 equals 5. 5 is equal to 5, check mark, yes, we got this right. Myla, if I said that right, good work. Yeah, sorry your computer crashed, but you're back in. That's great. As long as you come back in, I'm happy. Okay, so now this equation, this linear equation, we just solved a linear equation. Now somebody said linear means we have a straight line, but we're not graphing at all. We're graphing in chapter 2. So in chapter 1, we're just solving. And linear means that the degree slash exponent on the x here, on this x here, what is the exponent for the x? What do you think? If you don't see a number, Valentina says 1. So if you don't see a number, x like so, Nicholas says 1, you can hear me, that means that is the same as x to the first power. And to go even further, the coefficient, oops, wrong one, if you just see an x, this really means 1x to the first power. So the number in front of the x, which is called the coefficient, is 1, as well as the degree or the exponent. the degree is the highest exponent, which in this case is 1 as well. So, and that is what makes it linear. Linear, the degree exponent is equal to 1, and we have one solution. Now let's take a look, and nobody's here in the classroom, by the way. I thought somebody was going to come. Let's take a look. I'm always coughing in this classroom. I was trying to find if I had a cough drop. Probably have to get some water. Strange. Something in the air. Let's take a look at 3x squared plus 2x equals negative 5. Now, who can tell me what is the degree for this equation? I'll be right back. Let me drink a sip of water. Oh, man. It's this classroom. Come to think of it, the other time I was in here, I was coughing too. Okay, all better now. So, where were we? Degree. We have 3x squared plus 2x equals negative 5. Who can tell me what is the degree of this equation? Anybody? The degree of an equation is always the highest exponent. So what is the highest exponent that you see here? 2, Chloe, exactly. So the degree for this equation is 2. It is not 1. 1 represents linear. 2, when the degree is anything else but 1, then it is called nonlinear. So that would be a nonlinear equation. Nonlinear means any other degree other than 1. So 1 is strictly for linear.
So it would be.
What?
Okay, I had a question.
Yes.
So if the equation has an exponent, that would make it nonlinear?
Can you repeat this? I can barely hear you. Maybe if you turn up your volume a little bit.
Okay. Okay, so if the equation has an exponent, that makes it automatically nonlinear?
Yes, yes. If the exponent is higher than 1, or not 1 for that matter, could be a negative number, that automatically makes it nonlinear. That is correct. Yes.
Thank you.
You're welcome. This particular equation, and towards the end of the semester, you may have heard, if the degree is 2 on the equation, that means that we have a quadratic equations. So some equations have special names, like linear degree is 1, quadratic it's 2, but we don't really need to think about that now. We only have 2 choices. It's either linear or nonlinear. Nicholas says, isn't the degree how many times the line grows? Yes, good point. I was going to get there at some point. How many solutions depends on the degree? Is it the same as an exponential equation? Well, it could be. Exponential equations are also nonlinear. Valentina, that's correct. So the degree of your equation tells you how many times the graph, if you're graphing it, crosses the x-axis. So if we have a linear, it only crosses once. So here's the x-axis and here's y, so it only crosses once. And again, it's not about graphing, but sometimes we are visual learners, so when you're being asked to solve something, just like Nicholas is saying, it really means where does the graph cross the x-axis? And with a quadratic with degree 2, that means not always is this a case, but in general, it crosses at 2 places on the x-axis. So you have 2 solutions here. If we had an equation to the 3rd power, and you learned that in college algebra, you would have 3 solutions. If you have one to the 4th power, and then they're all called polynomials, poly means many, so higher than 4 usually, that's when you, so 4 degree would be, it crosses the graph 4 times. Cool. Okay, good points. I like how the chat's going. So we have a solution. We already figured this out, and a solution is just a value that makes the statement a true statement. Value that is a true statement, where the left-hand side now becomes equal to the right-hand side. Okay, cool. Now somebody's coming in. And when somebody's coming in, for some reason, it disappears on me. Here you go. Now, this is just a picture from the book. It's on page 2. We're talking about linear equations in one variable. And the linear equation in one variable has the form ax plus b equals c, where a, b, and c are numbers. So here in the book, like I said, it's on page 2. I hit the button too early, so I cut something off. But 2x plus 5 equals 20. A would be, in this case, 2. Why do they? Oh, it was 3x. I cut it off. So A would be 3, B would be 5. AX plus B equals C, and C represents 20. And then you see other examples here. So the general form, and here you see the word first degree equation. A linear equation is also called a first degree equation. That makes it linear. So next slide is, there's a general form again, but now you got to help me out. I have, this is actually here, we have 4, 5, and 6. I added those 2. We have 6 equations. You tell me if they are linear or nonlinear. That's all we want to know. We don't care what the name, specific name is, linear or nonlinear. So for equation 1, guys, linear or nonlinear? And you can type it in the chat. Yes, yes, what the, Valentina, yes means linear, I assume. Yeah, okay. So number 1 is definitely linear. That is a yes. Number 2, linear or nonlinear? Number 2 has a degree of 2 here. Here's my exponent. So that makes it nonlinear. Number 3, linear, nonlinear. I see your answers. So linear, Elijah said. He was the first one. Linear it is. So this would be nice if I were to give you a poll, but the poll didn't come up. So linear it is. It's like having clickers where you can just give me the correct answer. Number 4, linear or nonlinear? Nonlinear. That is correct. Let me see if I get some emails of people that can't get in. No, no. Okay. Now 5 and 6, they almost look the same. 3 over 5x plus 6 equals 12, and 3/5 x plus 6 equals 12. So what do you think? 5, linear or nonlinear? Rodney says nonlinear. Anybody else? Tanya says linear. I see a lot of linears. Now I have to go with Rodney on this one. Let me 5 over 3x. Yes, you don't see an exponent here. However, the x is in the denominator. So if you were to bring it up to the numerator, this actually would be 5/3 x to a -1 power. So when the x is in the denominator, that has a special name. It's called a rational equation. And we get there in chapter 6, not now. So in this case, that would mean it's nonlinear. Nonlinear because the x is in the denominator. And number 6, linear or nonlinear? Now you have 3/5 x. 3/5 x. The x is to the side. That is actually x over 1, and that would be considered linear. That is correct, Sonia. Okay, guys, any questions on linear and nonlinear? So some of these problems are in the back of your exercises for section 1.1. You're being asked if they are linear or nonlinear. Everybody good? You're also, okay. You're also being asked, you're given an equation and they given you an answer for x as well already. And they're asking, is x equals to a solution? That does not mean that you have to solve this equation. You're just being asked to see if x equals 2 is a solution, meaning this x here in your equation has to be replaced with 2. So don't solve this equation, just plug in the 2 for x, do the arithmetic, and then tell me, I always put a question mark here, is the left-hand side really equal to 9? So I'm giving this question to you. Is the left-hand side equal to 9? Okay, I see no. No, it is not. Yes, I mean, yes, you are correct. It is not. If you do the arithmetic, we have to multiply first. So that would be 6 plus 4 on the left-hand side. Of course, we all know that is 10. And 10 is not equal to 9. So the answer to this question over here is x equals to a solution is a no. No, it is not. So when we get a solution or they give us a solution, the left-hand side has to be equal to the right-hand side. So there are a couple problems like this in the book where they ask you to substitute the value for x and see if it is a solution. Then the next 20 or 30 problems is then actually solving an equation. So here's my first equation. We know it's the same problem. We know that 2 is not a solution. So now we're going to try to solve this. And I'll show you the steps from the book in the next slide, but let's see what we can do without looking at the steps so far. So this is a two-stepper problem. You always want to isolate and get x by itself. We don't have parentheses, we don't have fractions, we don't have decimals. By the way, you are not going to see many decimals from me because I don't like decimals. So I don't even think I picked homework problems that involve decimals because I usually don't go over them. Fractions is what it's important, fraction action. So we got to isolate the x. That means everything that is not attached to an x, like the 3 is attached to the x. So we're going to leave this alone for now. We have to move the 4, the number. And again, we have to do the opposite. So there's a +4, that means we have to subtract the 4. Everybody agreeing with me? Hopefully. Now we bring the 3x down. These guys cancel each other out, and we do the arithmetic on the right-hand side, which is 5. Subtract 4, right, Tony Ann? You are exactly correct. And now we're at the last step where we're almost down to the x by itself. But what are we doing with this 3? This 3 has to go. Now the original operation here is 3 times x. Of course, if you don't see a dot, that means multiplication. And the way we undo multiplication is by, what is the D word? Not the decimal. What do I have to do here? I have to divide. Thank you. So we're dividing by whatever the coefficient, the number is in front of the 3. So in this case, we're dividing both sides by 3, because 3 over 3 is really 1x. And remember, 1x is x, so we isolated the x. And on the other side, please do not change this to a mixed number. Don't change it to a decimal. In higher mathematics, everything stays as an improper fraction, if that's the case. So the answer here is 5/3. Done you are. Yes, Jordan, divide. Any questions on this one? Okay, then we're going to the next one. Now this is again a picture out of your book. That just eliminates a little bit of writing for me. How to solve a linear equation in one variable, and this is on page 5. So the first step is to simplify both sides, meaning if we have parentheses, if we have fractions, decimals, we need to clear everything. So parentheses need to be cleared by doing distributive property. That's how we clear the parentheses. Now we're clearing the fractions or decimals by multiplying by the LCD. If we multiply each term by least common denominator, then we can, the bad word to say is cancel, that's what you're used to. But what you really should say is reduce. The only time you cancel is you have a -4 and a +4. That's really the reserved word for cancel. You're not canceling out, like if you have 1/2 times 4 over 1, you're reducing. 2 goes into 4 2 times. You're not canceling it. It didn't go away. So anyway, it's just the way we said things early on in our math careers. So we're clearing the fraction, and then once all this is done, we have to see, are there any like terms on either side? So you have to combine like terms. And then step 2, 3, and 4 is what I call moving and shaking. We're moving and shaking things up. And I'm a creature of habit, of routine. You can do it any other way like you're familiar with. As long as you get the same answer, I'm okay. You don't necessarily have to do it my way, because the beauty about solving equation is you can do it different ways and you come up with the same answer. I just always say, what do I say? Numbers to the right and letters to the left. Some instructors say keep the variable positive. I can work with positive and negative numbers equally fine, so it does not bother me if the variable turns out to be, if the coefficient is negative. So, but again, if you are comfortable with one way and I do it slightly different way, you keep doing it your way as long as you have the right answer. If you get the wrong answer, we got to figure out what you're doing wrong. Any questions, guys? How's it going so far? Can you hear me? Can you see me? Do you like the teams? Everybody good? It's good. Thank you. Smashing. Oh, whoa. Going good. All good. Cool. Thank you. Yeah, and maybe, if you find some time later on, give me some feedback and see what we can do differently and what we can improve. And don't forget your Monday people, you know who you are. Group A is coming on Monday. Okay, let's take a look at a problem from the book. I said page 12, number 32. And that is in my book, 6 equals negative y plus 1. That is another issue students have. All of a sudden, the equal sign's to the left-hand side. And I'm telling you, let's say you had this problem on a test. Students tell me, oh, I like the little smiley face, thank you. Students tell me, I've never done this before. What? It's still a linear equation. You got to get the variable by itself. But sometimes students are thrown off, oh, the equal sign is the other side and I don't know what to do anymore. You should be able to do it both sides. But if you're totally against the equal sign on the left-hand side, guess what? Just put it over here. Technology makes me erase that 6 over on this side. Either way, this is still the same problem. It doesn't matter. So you should get used to, not making changes and say, oh, I've never done this before. Yeah, you have, but now either way. What do we do first? We subtract 1 from both sides. Negative y equals 5. 5 equals negative y. Okay, now negative y is the same as negative 1y. We're not interested in negative y, we're interested in positive y. So the next step is to do what? Who can help me out? Who can help me out? How do I get rid of this negative y? I need a positive y. I multiply or divide by negative 1. So no matter what, y is equal to a negative 5 because a positive 5 divided by negative 1 is a negative 5.